Hello everyone. First of all, I would like to thank the organizer, and above that, I would like to thank you for attending and sparing some valuable time for my talk, because I'm doing the freelancing, so I know the time is money. So that's why I'm not going to bore you with the bookish stuff and the IDE coding environments here. I'm going to take you through a journey of multiverse of cameras, synchronizations, and streams. So who am I? I'm actually leading the machine learning team at Rapidev, and I'm also a Tensorflow Certified Developer, and I'm doing some few open source contributions, and I'm deploying the real-time solutions in the field of retail, defense, and across the globe from 5 years. So what the actual problem that there is a lot of discussion in the Python community is actually in this meme. So I want you to read this and understand. Okay, so Python is good for the rapid development. If you want to just build the stuff and show the prototypes to someone, mostly it is developed for in this area, but it is slow for the real-time systems because it has some concurrency issues, and it is not actually concurrent. You can do the concurrency stuff using the multiprocessors, but it will then have some memory management issues. And this is all because of the famous and sacred GIL global interpreter lock, I think you have heard of. So here are some technical jargons that I'm going to use in this talk. I will tell you about the queues. The queues are nothing fancy, just a data structure in which the data comes in and comes out in the first in first out way. Then I will tell you about the microservices. I know in this conference there is a lot of hate going around microservices, but this is how in the enterprise applications it works. So in microservices, actually, this is mostly used for the independent development and deployment. So front end team is actually doing the front end development, the back end is doing the back end, and the AI is doing the AI thing, and they are deployed separately on separate machines due to the cost of AI things. Then there is a term coming in the PTZ functions. These PTZ functions are nothing fancy, just the panning, tilting, and zooming functionalities of the axis cameras that you can use in the security and retail. Then there's a word, the map reduce, which is again nothing fancy. It is just the breaking the batch of the objects into the parts and applying the process on them and then combining them. So for the anonymity purposes, let's say company X hired me to work on the product CVX. So how product CVX was working? We have multiple cameras that coming into the AI service. That AI service is written in the C++ due to the synchronizations and that batching and AI stuff. These cameras are passed through the AI services that will detect, recognize, key point detection stuff, and write them to a streaming service. This was a Redis-based streaming service. Why streaming services are used? Because in the real-time systems, you mostly cannot use the request response systems. So you need a messaging queue sort of thing. Then the backend services will pick the data from the streaming service, and they will apply the KPIs, monitoring, the alerting, notification, emailing stuff. They are also connected to different databases and write the data back to the streaming services, which is then picked up by a connector service that is nothing more just a socket service that is that fancy data displaying on the front end and dashboards and charts. This was all going well until we pitched it to a very heavy investor that has a lot of money, and he want to use this product, but he has some different sort of problem. He cannot use this as it is. He has a cart this type of thing, a cart where the objects and the boxes are placed, and these boxes have the barcodes on them. So what he wants, that he has the combination of the cameras, the axis cameras, the static cameras, and the paired ones. So he actually wanted to use these full capabilities of cameras to zoom into the object and then recognize either the correct box is in the correct cart. So this is some inventory management sort of thing. So what we did, actually we use the camera streams as it is in AI service, because we don't want to break the real-time flow of the system. So the problem is, actually he wants to use all the capabilities of cameras, but he want to keep it real time. So we actually introduced another service which we used to call OCR or QR service in our company. So all this multiverse thing is happening inside this service. So let me show you the service. So it has different components. There is a main process which has an input queue, an output queue, and a processor. So data is coming in input queue, then going towards the processor. The processor will do the fancy stuff and does not block the flow of the data. So it keeps it real time, write the data back to the output queue, and then back to the streaming service, which can then pick up by the backend services to apply their emailing KPI kind of stuff. So what is happening inside the processor? First of all, it starts by connecting with the database and check how many cameras are enabled. So it opens the separate processes for each of the camera. So if you have the static camera, then you have the separate process for them. If you have the PTZ camera, separate process for them, and for the paired PTZs again. So in the static camera, nothing happening, just the check. We are just checking that right object is in the right box, or the data transformations, some internal stuff, and then writing it back. There was no blockage here. For the PTZ cameras, we have actually a blockage here, because camera needs to go to the object, zoom in, then it has to stable to focus on the object, and then read the QR code, attach it back to the flow of the batch of the data, and apply the data transformation, write it back. So for this PTZ sort of thing, we actually applied the threading mechanism, and we use the queues and all of that stuff, so it will not actually block the thing. So this thing is happening in separate thread, and the threads can share the memory. So it has the same object, and whenever it detects that there is this barcode is attached to a QR code, it can write to that. And if we try to use the processor, it will not work, because processes does not share the memory. For the paired cams, we actually again use the PTZ functionality. In the paired cam, the scenario is that the static camera, they have a static camera and a paired camera. So for the AI services and the flow of data, we use the static camera. For the PTZ cameras, the paired PTZ, we apply some image similarity algorithms to actually transform the detection from one camera to another. Then we pinpoint the detection where we want to zoom in a separate thread. We zoomed in, we read the objects, the barcode, and apply the data transformation and write it back. Everything is good? No. Actually, the problem is that the developers don't want to change their code. Just because we introduce a service, it doesn't work. It doesn't mean it works the same way, because the backend developers are first receiving the data in a batch, in a list of dictionaries containing the objects and information from the AI. Now, when we introduce this all queuing mechanism, the data is break. So the product is not working anymore. We are having the delays and shaking things up. So then we open another process, a MapReduce process, that actually hold the data until it is complete. But we have a threshold that if a process is stucking or halting, we will ignore it above that threshold. So we are combining in this MapReduce process and then sending the data back to the output queue. So this is actually how we solve the problem of that client. and we used.
I have a question. Does this mean that using MapReduce simulation such a way that it becomes a batch process?
No, MapReduce is actually, just let me complete, so we will take the questions. So yeah, so we use the functionalities and capabilities of all the cameras, and let's bring an end to this presentation. So if you are still awake, let's have a Q&A. Yes.
My question was that first one you were using Q, right?
Yes.
And then you introduced MapReduce. What was the reason for introducing MapReduce first of all? And was it used for making it simulate such a batch processing?
First of all, the data is coming in a stream and going to the backend service. When we introduce the multiple processes in the multiverse, the data breaks down because there is a object going for a single camera, there is an object going for another, and we are writing that back to the output one by one. Now we need to combine that. So the MapReduce is actually just holding the data until it's complete and then sending back to the streaming service.
Are you using the raw footage or are you transporting it?
Raw footage.
And any step of the way, any kind of
Transporting?
Transporting.
No, it's actually handled by the Deep Stream. We were using the Deep Stream. Have you heard of that? So Deep Stream is a C++ based NVIDIA's framework that will handle the transcoding and all that stuff. And it actually, because we are using the NVIDIA's GPUs and AI real-time stuff, so NVIDIA's GPUs and NVIDIA framework will actually quite compatible in doing the real-time stuff. We tried with OpenCV, but we lose the real-time there.
And are these cameras having different frame rates, or do we have the same?
No, we have strict them to use the 30 FPS or 20 FPS. But yeah, when there were more objects in the AI service, the whole application slows down a little bit. Let's say it's dropped from 20 FPS, 30 FPS for each camera. If we add the 6 cameras, it will become 15 FPS. In the process, not in the camera. Cameras.